Well, hello everyone, and welcome to another episode with your crazy ass girl, Audrey Codner from ACG Math Tutoring. ACG Math Tutoring. We are going to be doing some math at 9:32 p.m. East Coast time. So hopefully you guys are doing all right. I know I sound like I feel like I sound like a DJ right now. And then we're going to put on the stins and twos. Anyway. So what we're going to be doing today, we're going to be multiplying and dividing radical expressions. So yesterday or last night, we were doing adding and subtracting. And a lot of you guys were still doing multiplying and dividing. So we should be able to get through this rather quickly. So as you guys come on in, go ahead and tap away. It was always good to see everyone. Hey, Lynette, good evening to you. Hello, Robert. Okay. I see you're here early. So ready to have some fun and hear some shenanigans as we're doing some multiplying and dividing those radical numbers. Insane. So, if anything, hello Bella. Thank you for coming on in. So, as you guys are taking a look before we officially get started, because right now it's at angel number 222, but I would love for it to be at the great number of 1K. So let's get it moving, let's get it tapping, let's get it grooving. So go ahead and tap on it, check on it. So while you guys are doing that, let me just kind of do a couple of things that's going on. So one, I still have some spots left for the great month of July. Before we know it, it's time for us to get right back to it. Our schedules are no longer going to be our summer schedules. It's going to be our fall schedule. Can you believe that? I don't know what happened. But I still do have a lot of one-to-one sessions that's available. Had a couple cancellations today, which I was able to get some stuff done. But if you are interested, maybe you are taking college algebra and getting ready for your final exam, which is about to occur on the 30th or the 31st of this month. Maybe you're doing college intermediate algebra and you're getting yourself ready for the fall session, which will be coming up in a few weeks, believe it or not. Or maybe your child is doing a summer reading packet with math and you got to the point where you're just like, yeah, I don't know what I'm doing. Okay, so, and then maybe your child's taking a prep course, or maybe they're doing a little bit of remediation and they need some assistance with it. Just go ahead and reach on out. So just for the month of July, I'm doing like a special for you guys for $47. This is just for my TikTok family, okay? Anyone outside has to pay $87. Look at that discount. Who else is giving that to you? No one, okay? So up to an hour, basically working on your own content, getting you ready either for homework, quizzes, or maybe even your final examinations. So that's what we're doing. We also do a little small groups. And if you're interested, just go ahead and DM me and we'll take it from there. All right. So if anything goes up and crazy with TikTok, this is where you can find me. All right. So actually, I got a better one that shows a lot better. So this is what you got to do. You go. All right. So actually, I got a better one that shows a lot better. So this is what you got to do. You go here. You type up here. And I want you to do this. You go here. You type up here. And I want you to do this, definitely this, and that. Okay? So just in case you didn't quite get all of that. All right? So that's where I go. That's where all the replays are. So just in case you can't stay for the whole time, that's where you can go. All righty? Sweet. All right, let's get it done. 8:15, guys, 8:30. We got this. Come on. I know you can tap more than this. It's almost like a regular text message for you guys. Come on. You're sitting here, maybe because you're tired from texting. Come on. Let's get it going. All right. I really don't know what happened to my music, but here we go. Oh. because I turned it all the way down. All right, there we are. Okay, all 50 of us, we're going to rock, we're going to roll. So let's go with multiplying radicals before we do anything else. So yesterday, we were doing a little bit of some things called radicals. We were adding them. We were subtracting them. But now, the key thing to know about multiplying radicals, you want to multiply whole numbers with whole numbers and radicals with radicals. All right? So if I want to say, if I have 2, the square root of 3 times 5. Okay? The only thing I can do with this, let me make it a little bit bigger for you guys. Only thing I can do with this is I can multiply the 2, because 2 square root of 3 is the same as saying 2 times the square root of 3 times the square root of 5. So here I can multiply the whole numbers with the whole number, which will give me 10, and then just bring down its radical, square root of 3. Okay? Also want to take a look to see if the square root of 3, if I can break it down. If I can't break it down, that means I can bring it down. Luckily, 3 is prime. But if I said 2 times the square root of 3 times the square root of 5, this time I can only multiply radical with radical. Okay, so this 2, that's going to be my trifinace friend. All right? Always want to holler at somebody. Always want to take your car but never put gas in it. If you're just like, I don't have friends like that, you might want to take a look at yourself. Maybe you're it. All right, so now we got 3 times 5. That gives me 15. So this is to show you, you can multiply whole number with whole number, okay? And that whole number is going to be your coefficient of that radical. Or you multiply radical with radical, and then you bring that whole number to be the coefficient of that radical. Now, what happens if we do a little mixture? So if we have 2 square root of 3 times 4 the square root of 5. Well, it's just like I said earlier. You multiply whole number with whole number. 2 times 4, that gives me 8. Square root of 3 times square root of 5, that means radical with radical. Multiply those things, you get your 15. All right? And then always just take a moment to look at the radical to see if you can simplify it, just like how we did yesterday. Now, if you're just like, but Audrey, I wasn't here yesterday. Well, this is where you go. Come on, boo-boo, I got you. This is where you go. This is what you type in. And then I want you to do this. Boom. I want you to do this and this. Definitely this. And turn this on. I won't be a nuisance to you. I'm not going to be one of those people that every 2 seconds you're going to see something from me. All right? But that's where you go to get, because I have all of my TikTok lives on there so you can peruse through at your thing. All right. All right. So, love it. Hey, General. All right. Good. So, let's do a little bit more advancement, okay? This is just to ease you into it, you know? You can't just go right into, like, hey, let's go right into that. We gotta ease into it, romanticize it a little bit. But what happens if I do this? Okay, let's get one of my other example. So let's say I have negative square root of 5. You're like, oh God, negatives, Audrey. Hey, it's not going anywhere, so you're going to have to deal with it. Times the square root of 20. All right? So, when it comes to multiplying, and I have it over here for a second in red. With the multiplication, you can do one of two things. Either you multiply your radicals together, then simplify, or you simplify, then you multiply. So let me show you through example. So right here, we have a negative square root of 5 times the square root of 20. So we could, if we wanted to, multiply the coefficients. This is a negative 1. Remember, if you don't see a number, it's assumed to be a 1. So we have a negative 1 times a positive 1. So we have a negative 1 times a positive 1. So negative 1 times positive 1, I'm going to put it down here. That will give me my negative 1. So now I can multiply radical with radical. So 5 times 20, that gives me 100. So now I can break down. So what I did was I multiplied. Now I'm going to simplify. So if I break down the square root of 100, I know that 10 times 10 gives me 100. So the square root disappears. It's gone because this was a square root disappears. It's gone because this was a perfect root. But this negative comes down. Okay? That negative is not under the square root. So I shouldn't see anything talking about complex numbers and i's. No. Okay? If that negative was, say, a negative 100 underneath that square root, yes, that's when you start talking about those complex numbers, those i's. Okay? I'm lagging a little bit. I don't think so. I don't know. I'm just going to keep on going. So if anything, the answer for this is a negative 10. So this is what we did. We multiplied, then we simplified. Okay? So as I don't know if I was lagging or not, but if I did have a negative underneath the square root, that's when you start talking about those complex i's. Okay? But we're not dealing with that right now. All right? So when we have that way, we got another way. Another way is that we could simplify, then we can multiply. All right? So I have my negative square root of 5. I can break down the square root of 20, just like how we did yesterday. So I'm looking for a perfect prime combination. So if you're not sure what it is, we're looking for 20. Here we go. We're going to 20. We have 1 and 20, 2 and 10, 4 and 5. 4 and 5 is going to be that perfect prime combination because 4 is a perfect square root and 5 is prime. So if we clean this up, I know I still have my negative out here. Square root of 4 will give me a 2. So this is taken care of. But then I have a square root of 5 times the square root of 5. So remember, we can multiply square root with square root. Okay? Radical with radical. That will give me the square root of 25. Because 5 times 5 gives me 25. But bam, square root of 25, that's a perfect square root. So we got negative 2 times 5. Now they're whole numbers. They can multiply, which will give me a negative 10. Now, me speaking very lazily, this is a lot. I like going right to the nitty of the gritty. But there are times that breaking it down this way is a lot better than doing it this way. Especially like if you're dealing with 4-digit numbers underneath that radical. Definitely. Sometimes breaking it down small is the way to go. All right? All right? Yeah. So here's my thing. Here's a shortcut just in case you haven't catched it. Every time you have the same number, which is called a radicand, Every time you have the same number underneath the same type of root, same type of radical, your answer will always turn out to be that number that's underneath that radical. All right, you don't believe me. All right, I'm just sitting here lying like I don't know what. But here we go. If you look at it, we got square root of 5 times square root of 5, right? Square root of 5 times square root of 5 gave us square root of 25. Square root of 25 is 5. Does this work every time? Is she really telling us the truth? Who knows? Dun, dun, dun. Yes, I am telling you the truth, okay? So even if I said square root of 6 times the square root of 6, okay? Square root of 6, the square root of 6 gives me square root of 36. Square root of 36 gives me what? 6. These little things can kind of save you some time and aggravation. Okay? You believe me? Will people ask for it one way over the other? Nope. General, that's a good question. My thing is, when they say simplify or they say multiply, they really don't care how you do it. As long as you pick A, B, C, D, or possibly E. Okay? So you choose which way helps you to remember and to get that answer a little more effectively. Okay? So, good question. Okay, so the radicals cancel out, basically. Yep. All right. Okay, so let's try another one. Let me see if I can save up a little bit of spacage coming here. All right, so let's try this one. Slide that over for you a little bit. So we have the square root of 12 times the square root of 15. Okay, square root of 12 times the square root of 15. Now, well, thank you. I tried to explain things pretty well. I just like to get straight to the nitty of the gritty. That's just me. Now, all radicals tonight. Yeah, we're going to do all radicals tonight. But again, if you need help, Jason, just let me know. Sorry. If you need help, Jason, just let me know. Because remember, I'll be available. All right. Hey, Janice. Hopefully you're doing all right. I'm telling you, hopefully I wasn't too crash tonight. Okay, not a problem. Not a problem. All right, so we can do one of two ways, as I said. We can either multiply, then simplify, or we can simplify, then multiply. So I'm going to try to take the multiplication a little bit up here. If I wanted to multiply first, what's 12 times 15? I'm going to take this up here for a second. Okay. Well, Steel Man, I got you. I'm gonna show you. That's why I'm here. I'm here for it. Hey, Zeb. Thank you. Okay, General, kind of close. Okay, Nikki, yes. Hey, welcome in. Danny, I think I said hi to you, but if I didn't, hey. All right. So we got 108. There we go, General. There it is. So it's a square root of 180. Now, anything ends with 0, you're always thinking about your tens times table. But I know if I break this down with 10 and 18, neither of them is a perfect. Okay, neither of them is perfect. So this is when we go to the handy dandy. We try to get to 180. All right, 180 is going to be over here. Here we are, nice and long. So for the 180, let me bring it up to some of y'all. Okay, we got the 1 and 180, obviously not. 2 and 90, 3 and 60, 4 and 45, 5 and 36, 6 and 30, 9 and 20, 10 and 18, and 12 and 15. So whatever's highlighted in red, we got our 36 and 5. So we can break that down. Oops. Zoink. There we go. So we can break this down into two radicals. We have our 36 and we have our 5. Now, if we were allowed to use our calculators, what I would have done is said, okay, take this answer and start dividing by your prime numbers. And I know for sure someone's going to divide by 1. 1 is not a prime number. The first prime number is a 2. Okay, so your first prime number is a 2 because the only way that you can get a 2 through multiplication is just 1 in itself, which is 2. All right, so square root of 36, that's a perfect square. That gives us 6. Square root of 5, that's prime. If I can't break it down, I'm going to bring it down. So this 6 radical 5 will be my answer if I were to multiply first and then simplify. Okay? Some people like it, some people don't. All right? So now, if you wanted, because a lot of you guys said you liked the second method better, if you want to break these down, what are two numbers that I can use to break down 12? What are my two radicals to break down 12? Okay, perfect prime. There you go, Daniel. Good. 3 and 4. Okay. Matt says 4 and 3. SA9407 said 3. Don't forget the other one. Kai said 3 and 4. It said 3 and 2. Not 2. Nike saying 4 and 3. What is it? It's Mick saying 3 and 4. Okay, not 3 and 5. Well, 3 and 5 will be the other one. Good. So I'm going to put my perfect in front and my prime behind. For the 15, there we go. We got our 3 and 5. Okay, if you use 6 and 2, 6 is not perfect. 2 is prime, but 6 is not perfect. That means I have to break down the 6. And then I'm doing a whole bunch of extra stuff. So try to shoot for a perfect prime combination. All right, so you got your 3 and your 5. Now, for those that don't know, the square root of 15 is one of those special square roots. Because as you can tell, if we try to simplify it, we get 2 prime numbers. All right, so it doesn't really do anything if you just have the 15 itself. But since we have our 4, which gives us a perfect square of 2, or square root of 2. But remember that little secret thing that I told you about? When you have 2 radicands of the same radical being multiplied, this will give you that whole number of 3. Remember that? Okay, and now what's left is that square root of 5. So now we got 2 times 3, bam, not to insult your intelligence, but I know you got 6, and we bring down the square root of 5. We get the same answer. You figure out where you feel comfortable, okay? I try, Steelman. Okay, I try. Okay, so this is all multiplication. This is all multiplication. Okay, talk to me here. How are we feeling? Okay, it doesn't have to be super, super complicated, but I'm going to tell you what would be helpful for these is knowing your multiplication tables and knowing your perfect squares and perfect square roots. Those are 2 things that's going to help you out. Okay, good, Danny. Good. Beast. Nice. Good. Radical, you're doing good. Sweet. Bring on the variables. Slow pace, Daniel. Slow pace. All right. Okay. All right, so let's try. Okay, let me up it before we get to division. All right, so if you think you got it, let me separate these real quick. Sorry, my fan is on. All right, so let's try this. Square root of 3 times the square root of 27 minus the square root of 3. Oh, what's she doing? What's she doing? Okay, so right now, my babies, we're not simplifying radicals. We're not simplifying radicals. We did that. Okay, we're multiplying and we're dividing radicals. Okay, multiplying, dividing radicals. So we're going with those as radical expressions. That looks gnarly? Yeah. Oh, yeah. Oh, yeah. Okay, taking it step by step. Okay, I'm going to give you a little chance to kind of like dabble into it a little bit. All right, I don't want people running. Hey, we're not doing this. Okay, we're not doing this fight or flight. We're going to fight. Okay, this is what we're going to do. We're coming across some math that you're probably feeling a little uneased. You're like, this is above my pay grade. No, sit your butt down. Relax. Listen to the music in the background. Open up your mind and give it a try. You'll be shocked and surprised what you learn and how much of basic foundational math is involved in this. Okay? Take a shot. You can't. Yes, you can. I was like, yes, you can. Okay? All right. So not 0. So JB is saying 3 square root of 3. All right. So let's see. Let's take it wild. Take a trip on the wild side. Just like we will normally do, we have the square root of 3 outside of a parenthesis. And inside the parenthesis, we have the square root of 27 minus the square root of 3. So, who remembers this? Who remembers that? Okay. All right, so I'm getting some 6s. I'm getting some 9. Square root of 3s. Yes, PEMDAS. Okay. We are still following the rules. All right. This is no longer the 90s. We don't put our bras outside of our clothing anymore. That was Madonna's thing. Okay. It's over. So now we have a certain system of how you get up out of bed. Maybe you stretch it different as you get a little older. You know, something creaks, something pops. You're like, what the hell's that? Yeah, all that stuff. But then you put your clothes on a certain way. You walk a certain way. You get your coffee done a certain way. There's rules, okay? Same thing is happening. Don't let the radicals fool you. So first thing, we do what's inside the parenthesis. So inside the parenthesis, we can't just straight subtract these two because they don't have the same radicands. This is a 27, this is a 3. Now, what we can do, we can break down that square root of 27 into 2 radicals and bring down that square root of 3, as well as this square root of 3. What would I get when I break down the 27? What are my 2 numbers? Not Madonna. I know. Almost like I can't recognize her anymore. Jesus, so much work. Yes, there we go. Beast 9-3, Rhonda 939, General 9-3, JB 9-3, Caitlin 9-3, Nike 9-3, Kaya 939. Hey, Dizzy, I haven't seen you in a minute. Okay, 9-3, Janice 9-3. There you go. All right, and Danny 9-3. Good. So I put my perfect in front, put my prime in the back. So now, square root of 9, that gives me 3. Bring down my square root of 3. As well as bring down this minus and this square root of 3. Okay? This square root of 3 outside, that's my trifling ass friend. It just keeps coming down. Okay? We're not going to do anything with them just yet. But we can do something inside this parenthesis still. What do we get? Thank you. All right. It's your retake. Okay. All right, Dizzy, you got this. All right. So what's happening in here? Yes, I'm seeing 2s. That's it, Daniel. There you go, Beast. Forget that question mark. Drop that. Okay, there you go, Beast. Nice. Zeb, not really factoring out, but we can combine their coefficients. Yes, there you go. Nice, Pop. Nice, Pog. There you go, JB. All right. There it is, General. That's it. So now we have 3 minus the 1, so that gives me 2, and I bring down the radical 3. When you're adding and subtracting, you don't do anything to the radicals except to find like terms. That's the only thing you do. All right? So now we basically got everything done in the parentheses. All right, so that's done. Boom. Do we have any exponents? Nope. Nope. That's done. Let me not forget to bring my trifling ass friend down. All right. So now we got multiplication, just like what we were doing, right? So from left to right, the only thing we have is multiplication. So this is the same as saying, if you want to distribute, your 2 times the square root of 3 times the square root of 3. Because remember, you multiply radical with radical and whole numbers with whole numbers. So here's that little trick again. Isn't it nice to learn little tricks that you can kind of get right to it? Hey, tricks is not always for kids. I know, I've seen videos about it. But anyway, so we got the square root of 3 times the square root of 3. That gives me a whole number of 3. And then what do I do with this 2? This 2 was being multiplied to those. So it's 2 times 3, which gives me an answer of 6. Okay. Yep, no exponent. Wait, what happened? Okay. How did the 3 turn into a 2? The 3 didn't turn into a 2. Square root of 3 times the square root of 3. Remember, when they're the same radical with the same radicand, the answer is going to be the whole number. So if I may take it the long way, square root of 3 times square root of 3 gives me square root of 9. Square root of 9 gives me a whole number of 3. That's where this 3 came from. Okay. The third line. What about the third line? Hold on. Let me see what your question was in the beginning. I just heard the third line. Okay. Oh, Johnny. You want to hear something fun? Today, I got a message from a young man that wants to be a barber. So he's trying to get into this barber college. Guess what? He can't get in. And guess why he can't get in? Because he didn't pass the math part of algebra. So now, guess who's tutoring him to help him to be a barber? A barber. Okay? So if you want to talk about, when are we ever going to use this in everyday life? We're using it in everyday life every day. Okay? All right? So people, here's my thing. I used to say the same thing. So like, even though I'm mimicking you, I used to say the same thing. And the reason why I said it, because I didn't know how to do it. And I felt really insecure about myself. So that's why I always had to step it up. People are starting to take tests for basic jobs. I had another student that had to take an algebra test to be a receptionist of it's not a nail salon, it's like a beauty bar or something like that. But to be a receptionist. So we can mimic this all you want. You gotta jump through all these hoops. So I'd rather give you the ability to jump through the hoop and then break it once you get through it, and then you can do whatever you want to do. Okay? Love it. All right. Middle or high school? This would be considered high school. This is high school. Okay. I'm just talking, give you an example. Well, one, I need for you to check your tone and act like you got some home training. Okay? You don't have to come in here and do all that. Anyway. Yes, you're reaching your 7th grade math for the first time this year. You realize how perfect. I'm so glad I'm doing. Okay. So, yeah. So this will be considered, actually, the introduction will be like Algebra 1. Believe it or not. You guys have to, I'm telling you, it's hard for me to say it to you, and I'm so sorry. But when it comes to what we used to think was Algebra 1 when we were in school, it's fast-tracked now. So if you haven't, like, maybe you don't have kids, maybe you look at your niece and nephews or maybe your neighbors and just ask them, like, you know what, let me see what your math looks like. You're going to be like, dude, I had that when I was a junior in high school. You're learning this as a 7th grader, you're going to be shocked. You're going to be shocked and surprised. Okay? So trust me. Like, we can't even say, oh, is this 7th grade math? Is this 8th grade math? We can't even do that anymore. And I know here in Maryland, we're going to come across, so in Maryland, like, we're thinking about doing Math 1, Math 2, and then for high school students, that's what I can think of right now. So it's like Math 1, Math 2. So each of them is like algebra, geometry. It's like algebra, geometry, and statistics for both years. And then the third year, they're going to figure out, do they want to, whatever they want to do for something else as a filler for the third year, as a fourth year. Like, you're giving the students choice. If you give students choice, they're going to be like, I don't want to do math. Like, they're not going to choose something. But yeah, so they're considering that. Everything's going crazy. Everything's going crazy. In New York, yes. See, that's what I'm saying, Daniel. Here's the thing about Maryland. I'll snitch. I don't care. They have been copying New York style for years. Remember that, what was it called? Not Impact Math. Engage NY. They had someone have the audacity in Baltimore City to take your Engage NY, scratch out NY, and put MD. That was like about, it was before I started tutoring, so about like 6 years ago. Hilarious. I know. It's hilarious. If I find it, I will post it. I do not care. Come at me. I don't care. All right. So, anywho. So, if anything, let's see. Here we go. Let's try another one. So, let's say the square root of 2 times the square root of 6 plus the square root of 10. Yep. See, here's my thing, Daniel. Once you got rid of your stuff, all these other states start snagging it up. They're like, oh wait, this curriculum's already done, and we can get it for cheap. Cool, let's do it, and let's give it to the teachers like mid-year. Tell them to forget everything, and yeah. But we want the kids to advance and to excel, and we want to see growth in a matter of like 2 weeks. Yeah, that's why I'm not in the classroom anymore. Crazy. I do tutor pre-calculus, not that AP pre-calculus that they're doing nowadays. Like, why? Why does everything have to be AP? And I remember AP, you had to have like an 87 in order to be in an AP class. And I remember when they dropped it to a 75, if I'm not mistaken. And it's like, what was the point of AP classes? Crazy. Yeah, so just let me know. All right. So in this case, we can do the distributive property. Now, the reason why I say that is because the square root of 6, that's one of those special radicals. Because if I try to break down the square root of 6, I'm going to get 3 and 2. 2 prime numbers. Okay. So if I try to break down the square root of 10, that's also one of those special radicals. Because I try to break down the square root of 10, I'm going to get 5 and 2. That doesn't help anything. So since I can't get a perfect out of any of these, the best thing to do will be multiply. Do that distributive property. Okay. Wait, what? What's happening? Difference between life and kidney failure. What? What's happening? See what happens when I'm sitting here trying to do math? And people are talking about some crazy stuff. Alright, I took AP Calculus back in the day, and it was really hard. Doses of kidney medication. Oh, solving this correctly could be to be able to do that. Haven't practiced in years. Okay. Alright, okay. Now I'm good. I'm jumping into conversation. I'm like, say, what? What's happening? I'm like, guys, we're just doing math. You don't need kidney failure. All right. So here, square root of 2 times square root of 6. Radical with radical, we can multiply those. And that will give me a 12. Square root of 2, square root of 10. Radical with radical, multiply those, and we can get a 20. Okay. Yeah, I see now. At first I was a little concerned, and then I was like, oh, okay. All right. Aw, well, thank you. Okay. So now, square root of 12 plus square root of 20. What could I do next? Yes, I love it. 3, 4. Except for the last one. I don't know about the 3, 5. 3, 4, I got that. And 4, 5. I got that. Joel, 4, 3, 4, and 4, 5. Okay, Lucas, 6, 7. All right, are we doing 8, 9, 10, Lucas? What are we doing? 6, 7? Come on. Let's think it out. JB is saying 4, 3, and 4, 5. Okay. All right, so good. We have the square root of 4, square root of 3, plus square root of 4, square root of 5. Okay, got those perfect prime combinations. Right? Okay. Careful. Slow down. Because right now, we're going to simplify, but we're officially adding. Okay, we can't be jumping into cancellation right away. So the square root of 4, that gives me 2. Square root of 3. Square root of 4, that gives me 2. Square root of 5. Can I add those two together? Hey, you're back. Where'd you go? No. Okay. Nope. You're not sure? Okay. Okay. All right. So, we do not have the same radicals. Well, we have the same square roots, but we don't have the same radicands, the same number underneath. When we're adding or subtracting, they have to be exactly the same in order for me to combine. So this is your answer. That's as far as we can go. Yep, there you go. Nope, no more factoring out. Nope, nope, nope. Okay, no more factoring out, right? Okay, you see it now? Good. All right. Yep. So because they do not have the same radicals or radicands, you cannot do anything with their coefficients. Only if if this was a 3, yes, have fun with the coefficients. If this was a 5, yes, have fun with the coefficients, but they're not. Okay. Exactly, General. There you go. Yep, you can. But if they're saying for us to factor it out, it has to be no parentheses. That's the only thing that's different, Daniel. Okay. Hi. How are you? I haven't seen you in forever. Everybody's coming back. I was like, I haven't seen Sasha in a moment. So if they do match, that means you add, or whatever the operation that's in between, you're going to do the coefficients. So say that, for instance, instead of a 5, this was a 3. So that means I would add the coefficients. So my answer would have been 4 square root of 3. Because I would add the coefficients if they were the same, but they're not. Okay. Awesome sauce. Okay. All right. Good. It's all right, damn Yankee. And nice to see you. I'm glad you came back. Never once you use a calculator. Yeah, I know. So they'll make it something like this. So here's my suggestion. After you do a couple problems, or like say, let me go back. So let's say for this problem here. After you notice that if you multiply, you get square root of 100, and you know the square root of 100 is 10, look at your answer choices. If you see some crazy answers, automatically delete them. Okay? Boom. Process of elimination. I think it will work best for you guys to narrow your answers down. So if they give you 4 answer choices, do some of the work and then look at your answer so you can narrow it down. And then you can just focus on possibly the 2, or maybe you might be lucky enough you would have just that 1. Once you see negative 10, boom, that's your answer. Don't celebrate. You're supposed to know it because you are very intelligent. You got this stuff, guys. Okay, no more flights. All we're doing is we're staying and fighting. Okay, so when you're going to take that test, don't let the test define who you are. You know who you are. You just need to get past this test so the world gets to see who you are. All right? Okay. Getting off my soapbox now. Why are you being morbid? Robert, what's going on? This is what happens when I don't pay attention. It's not like I don't pay attention. Oh, okay. All right. Okay. Okay. So that's all right. Because here's the thing. It's coming. It's coming. Now, that's multiplying. Let's dabble into dividing. And then we're going to wrap all this stuff up. Okay? So, with division, zoinks. All right? Let's get that up to 20. There's over 200 people in here. Can we do a quick mad tap before I get to the division? Can we get to like 25 and like a heartbeat? That should be really quick. That should be mad quick. You did better in pre-calc than calc. Well, all right. Okay, let's get to 25. Let's do that. Let's do it. We got that. Don't leave just because now I'm asking you to tap. My goodness, the audacity. I mean, you're getting basically free tutoring. Really? Hello, Blaine. How are you? What's my record for a live stream? I think the furthest we have gotten, what I know was over 100. What was it? But I'm not going to stay that long tonight. Like, lately, I have a lot of things I have to cover. What was it? Oh, yeah, Robert knows. 130s? Okay, yep. Awesome. I know, right? People just be mad tapping. All right, almost there, almost there. Keep tapping, keep tapping, keep tapping. Wow. Let's see, there's nothing wrong with being a nerd. Have you noticed that the nerds are controlling the world? It's weird. It's like nerds are controlling the world, or they're the ones that's bringing a lot of the creatives in. But then the ones that are holding the 1% of finances are high school and college dropouts. Think about that. What the hell's going on? I suppose they have more education than our 1%ers. But, yeah. What's going on with that? Yep, and sociopaths. Right? Talk nerdy to you? Easy, buddy. It's not that type of channel. That's the OnlyFans page. I'm just kidding. Can you imagine? They have OnlyFans for everything. I would not be at all surprised. Would not be at all surprised. Good gravy. Yep. Yeah. Sometimes they come in, sometimes they don't. But again, it's a Tuesday night. It's after the 4th of July. You know, some people are probably away on vacation. I'm expecting like my numbers to kind of go back up once people go back to school and they really need assistance. So it's going to happen. All right. All right. Thank you. Appreciate you. Here we go. Now, for division, just like everything else, there are rules. I know. But some of the rules are pretty somewhat self-explanatory, or kind of close. The first rule is there are no perfect squares, okay? We can't leave a perfect square in the radical. So if I tried to say break down, I don't know, the square root of 75, I know I need to factor out the square root of 25. Okay, I need to break it down. So I can't just leave it and say, oh, my answer is the square root of 75. Nope, they will mark it wrong. Okay, that will be wrong. And the weird part is that square root of 75 will be part of one of the answers. Always look to simplify. Okay, now no fractions underneath the square root. And then we can't leave a square root or radical in the denominator, and we always need to reduce. So let's kind of go over a few of them. Not going to make it too crazy, but just crazy enough for us to get a nice little sweet little taste out of it. All right, so when I'm saying, let's see, we're going to write division here. So if we have, let's say, make sure you guys can see it. Okay. So if we had, say, the square root of 21 over the square root of 15. Okay. Square root of 21, square root of 15. First off, we can't have a square root in the denominator. That's one. But always see if you can simplify. Remember what we did with multiply? Either you multiply first, then you simplify. But for division, let's see if we can simplify and then we can actually divide. So I know the square root of 21. That's going to give me the square root of 7 times the square root of 3. Okay. Square root of 15, we've already talked about so many times. That gives me the square root of 5 and the square root of 3. What do you notice? What do you notice? Okay, Beast is saying cancel the root 3's. The 3's cancel out. 3 cancels out. They're multiples by root 3. Yes. Okay, these can cancel out. Since we got multiplication going up top here, we got multiplication going bottom down here in the denominator. But anytime you have something being divided by itself, that will give me 1. But I don't really need the 1 because I still have this square root of 7 and that square root of 5 playing around with. So let's clean this up. So we have the square root of 7 and the square root of 5. Now remember the rule, we can't leave a radical in the denominator. So what we're going to do, we're going to multiply the numerator and the denominator by our denominator. The reason why this will be the square root of 5 and this will be the square root of 5. The reason why I'm multiplying whatever I do in the denominator, I have to do in the numerator. But the reason why the square root or the radical 5 is because, remember that little short tip that I gave you? If we have the square root of 5 times the square root of 5, that will give us a whole number. So now we don't have to worry about that rule of having a radical in our denominator. Okay, let's see if I unzoom just there. Oops, psych. So now my numerator, I got the square root of 7 and the square root of 5. 7 is prime. 5 is prime. So right away, I know I won't be able to break it down to get a perfect out of it. But I don't want to leave 2 radicals in my answer. So this is why you just multiply. So you get your square root of 35. All right. Okay. So, and I know you're tempted. I could sense it. I know a lot of people are like, go ahead, divide the 35 into 5. No, because the square root of 35, that's a world all in itself. Okay, let me prove to you. Trying to do this in the dark, which is hilarious. Okay, so square root of 35, look at that. Okay, that doesn't give me a whole number of 35. That's a world in itself. Okay, so we won't be able to simplify by just dividing it by 5 and get a 7. No, sir and ma'am. Okay, so since the radical is in its world, the whole number is in its world. Remember, we can multiply radical with radical. We can multiply whole number with whole number. Same thing is going to be for division. Radical with radical, let's get it done. Whole number with whole number, you can get that done. This is my answer. Okay. What does it look like graphed? You want to graph a square root, which has one starting point and it goes out? Not like a check mark. How should I say? It's like a half of a sideways parabola. So the practical use of these equations, just to simplify expressions. Because I know what radicals, you usually see it, well, some of us usually see it under quadratic formula. And then when we have to break down the quadratic formulas. Can you flip the square at all? Why? For funsies? Flip the square? Oh, wait. 6 on 6 is 36, so the square root 35 will be close to 6. Yes, it'll be relatively close to 6. Yes, it will. That is for funsies. Do the problem before again, please. Okay. Can I do the problem before again? Oh, what, this one? Yeah, you'll see it on the replay. All right. Okay. All right. So now, let's get... So if we have, let's say this, -8, can you guys see it? There we go. -8 over 2 square root of 7. Yeah. It's always interesting, General. It's always interesting. All right. So we can do one of two things. Before we start tackling this denominator, we can simplify our numerator. What would I get after I break down the square root of 8? Like completely break it down. What would I get for a final for the numerator? Okay, so we have 2 square root of 2, 2 square root of 2, 2 square root of 2 is 2 root of 2. Okay, you had your 4 and your 2. True, because if you have your square root of 4 and your square root of 2, square root of 4 will give you 2. Square root of 2 will come on down. So you see how we can simplify, and then we're going to see if we can divide. What happens next? What could happen next? B says cancel the 2's. Okay? So we got 2 and 2, they're done. So that means what's left is square root of 2 over the square root of 7. But what's the problem now? Good, we can't have a square root in the denominator. There it is. So we're going to multiply the top and the bottom by the square root of 7. Yes, What's that called? Rationalizing that denominator. Good. You can't have a square root in the denominator. Excellent. All right. So that means we multiply both the numerator and the denominator by whatever that denominator is. So I forgot who said this earlier. There was a square root of 14 over, remember our shortcut, square root of 7 times square root of 7, that will give us our whole number of 7. So the reason why we're able to get that 14, because we had the square root of 2 times the square root of 7, radical with a radical, they can be multiplied to give me the square root of 114. There you go. Excellent. All right. Final answer. I know you're going to be tempted to say, hey, 14 divided by 7. No, don't do it. Don't touch it. All right. Okay. Questions so far? So I want to give you 3 more and then we're done. You almost got it. There you go. Alright. Oops. Hold on. There we go. Okay. Do you post your lives? Yes. I guess you came here a little bit later. Yep. You go here, and then, let me see if I can, hold on a moment. There we go. Okay. So I go here, you go here, and then you do this, 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 and this. All right. Okay. Yep. Don't worry, it's there. Okay. Right. So Nike, good. All right. So we have a fraction underneath the radical. So guess what we can do? Give them their own radicals. After we give them their own radicals, what could we do next? Okay, so if there's ever a fraction underneath the radical, give them their own radicals. Yeah, give them their own ones. Yep, now we got to rationalize it. Yes. So that means we are multiplying the numerator and denominator by the square root of what? By root 7. Good. Okay, by that root 7. Good. There we go. There we go. So what would I get as a ratio? So JB saying square root of 70 over 7. B's saying root 70 over 7. Damn Yankees saying square root of 10 times the square root of 7. Okay, so that means you can multiply those two square roots. Remember, radical with radical, that's perfectly fine. Okay. Something over 1. Not over 1. So square 70 over 7. 1. Not 1. Okay. Okay, addicted to success. Don't forget your radical. I think you probably said it earlier because when I saw something. All right. So we have radical with radical. We can multiply those. That's perfectly fine, which gives me the square root of 70 over. If I want, I can do square root of 7 times the square root of 7. That gives me the square root of 49. Square root of 49 gives me 7 because it's a perfect square root, right? Here's the shortcut. If you have the same radicand, which is underneath the radicals, and you are multiplying them, it will always give you the number without the radical. Now, I know it's going to be tempting to think about 70 and 7. Oh, let me go ahead and divide that and get the square root of 10. No. And here's the sad part. Square root of 10 will be one of those answers. But let's take a look at 70. So, looking at 70, I have 1 and 70, 2 and 35, 3 and 14, and 7 and 10. Notice I don't have a perfect prime combination. Okay? Square root of 10, that's one of those special square roots that will give me prime factors. Square root of 14, the same exact thing. It will give me 7 and 2, and that is going to be prime factors. Same thing with 35, 5 and 7. So right now, we don't have any kind of perfects within the square root of 70. So guess what? This is my final answer. That's factored all the way down. Okay. All right. Yes. All right, so let's try this one, and then I have one more, and that is it. So okay, square root of 14. See, you were right. Look at you. So the square root of 14 over y squared. Careful, Janice, careful. Because you're thinking of multiplication. Okay, you're thinking of multiplication. Or, I'm sorry, you're thinking about exponents. So, kind of saying square root of 14 over y, square root of 14 over y. From JB, Janel's like, oh my God, it's okay. Janice is saying 4, black and white something, saying square root of 14 over y. Lola saying 14 over y. No problem. All right. So remember, if you see a fraction underneath a radical, the easiest thing, because we're all visual learners, is to break them into their own square roots or their own roots. Now, the numerator is a square root of 14. That's a prime root. But your denominator, that y is being raised to the second power. This is a square root. Square roots and squares, they're inverses of each other. So when they're inverses of each other, they cancel each other out. And what do they leave us with? They leave us with a y that is not underneath a radical. Okay, good. Exactly. And if we get that limitation, y can be anything except for 0. Okay? Because there is no O below. Today I came with a permission. I don't know why. So a lot of people always get when something is undefined or not undefined. So for some reason, I don't know why this came to me. Don't know. The sun rises above ground. The sun doesn't rise below ground. So when the sun rises above ground, this is a 0. When the sun rises below, which doesn't happen, that's undefined. Because everyone always use everyone always use the sunrise for horizontal slopes. They always use horizontal. Anytime they talk about horizontal, anything horizontal. Oh, it's just like horizontal, horizon. There you go. So why not keep with that flow by saying the sun rises. That's when you get your 0. It doesn't rise on the ground. Be undefined. All right. Hey, thanks. I'm glad Robert was able to answer your question. I'm not gonna lie. All right, not a problem. Thank you for showing up. All right, we got one more, and then I am complete. All right, here we go. It's just been crazy. And then I have my little 2 cents, and then I'm done. So, square root of 27, square root of 27/16. What is my answer? So here's the best thing, addicted, it's okay. Remember, we got the replay. And there's always a replay. All right, so Robert's saying 3 root 3 over 4. Okay, Kai's saying 3 root 3 over 4. Replay where? I love everybody. It's so funny. It's like, what? Where? Okay, but give me some time to download it because sometimes TikTok takes forever. Because I'm still downloading the live from this afternoon. Yes, the struggle is real. This is why I don't go to bed until 3, 4 o'clock in the blessed morning. Okay, so yes, there you go. Go here, fill out here to get the replays. Also subscribe. It's a free subscription. All right. All right. So we got 3 root 3 over 4. Good. 3 root 3 over 4. Yes. 3 root 3 over 4. Brush. Okay. Yep. My wife may need this. I'll get her to sort out too. All right. Awesome. Yep. And plus I have some other things, but I'm going to share that after we're done with this. Okay. So again, you have a fraction underneath your radical. Let's give them their own radicals. And you can tell from the denominator, square root of 16, that's a perfect square root, which gives me 4. But the square root of 27, that needs to be broken down. And we did that today, actually. That gives me the square root of 9 and the square root of 3. So square root of 9, that's perfect, which gives me 3. Square root of 3, that's prime. So if I can't break it down, I'm going to bring it down. All right. And that's how you got your 3 root 3 over 4. All right. Lovely. Okay. Awesome. So, if anything, there's a couple things. Just stick with me. If you are And especially, let me do this before I talk about my books and all this fun stuff. But most important, if you are someone that's thinking about taking the GED, like coming soon, GED, ASVAB, the TEAS test, or maybe even college algebra. There's a lot of people that are taking the summer courses, and I know your final is either the 30th or the 31st. And taking tests freaks you out. What I'm doing is I'm going to have a mock practice test. So you're going to sit down, you're going to be hitting on all the concepts, most of the general algebra components that's faced for all of those examinations. And it is 35 questions. You're going to sit down for 59. So basically, tell the kids to go somewhere, sit down, don't touch nothing, that's it. Your significant other, I need to be by myself. I need to get this done. And really put you in that testing situation. Sit in a quiet place, at a desk. You're ready to take on some of the problems, okay? Then, after we take the test, I'm going to review the answers step by step. So, like, what are some of the things you should be thinking of? What are some of the tricks and tips to kind of narrow your choices down? Now, you can get the replay and copies of the test and my notes for $25, but there is an entry fee of $10, and I was going to keep it to just subscribers, but I'm going to say, you know what? It's going to be $10 for subscribers and non-subscribers to my TikTok, but my subscribers, you will get a discount on the replay, okay? On the replay, the test, and all that stuff. And we're actually starting tomorrow. Okay, so tomorrow at 7 to 9:30. So we're going to have 6 different sessions. Each session is a different test. So you're not just going to be given the same test over and over again. That's silly. All right. So every time you sign up, right now, I just need you to sign up for my email because I did have a breakthrough just before this live. So as soon as I get myself situated, I will actually be able to share that link. I'm going to see if I can come on live early tomorrow. I'm going to probably see if I can do because I have someone at 1 o'clock. So I'm going to come on probably like around 11 and just promote it so you guys can get the link, unless TikTok will shut that promotional thing down, which it has done before. But I don't know. I'm still trying to figure life out. But this is something that if you're really interested into it, let me know. Okay. Also, if you want to, I have some other resources that I do. I do private tutoring, yes. Small groups as well. Okay, so if you're taking a college algebra class and you and maybe 3 other people are just lost and confused and you're tired of being lost and confused, we can have a session together. Okay, I also have self-paced courses for GED, ASVAB, ACCUPLACER, TEAS, and even foundational algebra. It's like 107 videos. There's practice sheets in there, as well as a couple quizzes here and there. If you just want the course and you want me to leave you alone, the price is $147. But if you want, since it's the month of June, this is still going to be 4 sessions. You can get the course plus 4 30-minute tutoring sessions with moi. You're lovely. Okay? If anything, go ahead and go to this place. You should see it as one of my links up there. I know, I can't say these things because I get dinged every time I do. Now, if you like my books, you've been seeing it. This is like my whole notebook here. This is book number 5. What I do is I basically copy my notes down. I have a section for formulas, have a section for steps, and as well as that, in the back, there is a resource page. So the resource page, we've been talking about this factor sheet for a while. The rules of integers, the order of operations, properties of exponents. Talk a little bit about linear and quadratic equations. Then we go into properties of quadrilaterals, Then we talked about volume and surface area, also area and perimeter and circumference, as well as the unit circle, which you'll probably see in pre-calculus, and the Pythagorean theorem, and SOHCAHTOA and other trig identities. So all of this, plus 100 pages of notes. Usually, because I do these lives, I make my notes rather large. But if you write smaller, this could probably last you like for half a year. So you probably just need 2 books. But for me, I kind of like to write big because for you guys. So that is my math notebook. And if you like, oh, where'd it go? There it is. So if it's not the math notebook, if you want my notes, you can get Audrey's notes. Audrey's notes is a copy of all of my notes that I've done on my lives since February 2nd. Okay, so right now I'm working on book 5. So this is book 3. And if you notice, with Audrey's notes, they all have a QR code at the bottom. If you scan this QR code, it will take you directly to the live that is connected to this page. So it's like having me as your tutor, breaking down concepts like adding, subtracting, radicals. Who knew? And when was this? April the 24th. So it's kind of weird how it just opens up to that. Okay, adding, subtracting matrices. We have some probabilities. We have some distance and rate time word problems. So if you're interested in any of those, you can definitely go to my bookstore. Zoink. Okay. Books by Audrey Codner. So you have the math notebooks on sale there. We have the Audrey notes on sale. Soon, the left-handed books will be on sale by the end of this month, as well as some of my updated notebook resources will be there as well, especially Algebra 1 and Algebra 2. Geometry, for some reason, I got to put a hold on it. It's just too crazy. And I really want to make sure I got all the proofs on there. I mean, it's going to be a bear of a book, and then you're going to have to pay like almost $30 to $40 for one book. That's crazy. I don't know. I don't think I have the justice to do that. That's just too much. So that's why I had to put a hold on the geometry. But you can, I will put some of those geometry components in the regular notebooks. So you can still use this for geometry. Okay? All right? You need one. I know I like geometry too, but the proofs, I'm serious, Pug. Like, I can't. I'm not money hungry. I try not to be. I mean, sometimes I know I sound like I am, but I really don't. I really don't want to be money hungry. And I think that's just a lot. And especially, back to school is coming back. All the back to school sales are coming up as soon. So that's why I'm trying to get all these notebooks and trying to get everything in there as possible. All right. Okay, let me see. Okay, you think you're going to do this test? Okay, make sure you DM me so I know. Here we go. Let me go. I make it look so easy. Oh, it's not. Root 3. Okay, correct. I think I'll do this test, Audrey. Okay. Yeah, so just make sure you DM me. Please, when do you start? When you mean when do I start? Like, when do I start taking the practice test? Or when do I start courses? Or when do I start selling stuff? Just emphasize a little bit. Okay. Are you doing it on Zoom? Yes, I'm definitely doing it on Zoom. Yeah. I don't need any people photobombing and trolling and all that stuff. No one needs that, especially after you pay for it, So, yeah. And, okay, you need that one? Yes. So definitely go to Books by Audrey Codner to get yours. I know I could split it into 2 books. Calculations in one and proofs in the other. I probably could. But it's a lot. Especially like when you're trying to keep the books around like 127. Have you seen how many proofs there are out there? Holy hell. When I started typing, I'm like, wait, and I have to do this, and then you have demonstrations, and then you have to have the chords, and then I have to do this, and then you have demonstrations, and then you have to have the chords, and then the diameters, and then the inscribed angles and inscribed triangles, and then, oh my gosh, just talking about it makes my head spin. Yeah, I'll think about it. But I think right now, let me get the Algebra 1 and the Algebra 2 out. So that'll be out and ready for people. Alrighty. Okay, so again, if you are interested into the mock practice, hey, just let me know. Just send me a message. I'm also looking at my requested messages as well. But please don't just say hi. Like, tell me what you need. Because when you say hi, I just delete it. Okay, I got too many stalkers. Not to say that, I'm the shiznit. I'm not. I just got way too many stalkers. Okay, so if anything, yes, sit here, follow each other if you can. And that was the other thing that I forgot to say. As soon as I can find it. Here we go. So here's a list of people that you can follow or you should follow. One is Robert. He's in here. Okay. And then if you're looking for an elementary reading or math tutor from K through 8 or K through 5, make sure you follow Read Math Grow. We're trying to get her to go live as well. Then we have our pre-K and our kindergarten homeschooling. If you're thinking about doing that, but you need some resources and some assistance, make sure you visit my girl Nancy, who is the online elementary tutor. If you want to learn, Lynette was on earlier, but she's probably going to be coming on in about the next 55 minutes, doing abacus math. So learning with Lynette how to add, subtract, multiply, and divide using the abacus. And if you need a chemistry tutor, make sure you follow Professor TK. And if you want to do more work with Impact Math 19 on T's, ASVAB, and GED, she does a lot of sample problems that she does a pull. Like for me, I teach concept. She teaches the actual things of test. So if you got a combination of the two, you should be doing well with the test. And last but not least, a blessed RN. If you need some assistance, you're trying to get into nursing, but you need some assistance on your doses calculation, make sure you visit a blessed RN, and she'll be able to walk you through it. She has a really cool concept of doing it. Alrighty. All right. I think I have like 2 more people to add to my list, but I'm still waiting to hear from them. But I think it can be beneficial for you guys. I'll just chalk it up to we're not besties, but their stuff can help you. So I'll put that on my list sometime tonight or tomorrow morning, meaning in the next hour. Okay. All right, everyone. Thank you so much for staying here. Thank you for liking and tapping. I know it was a pain in the neck. Everyone's always shooting for like 50 and all that stuff. I mean, I appreciate anything. Like, I really do. I appreciate the time and the effort that you guys have. Robert, are you going live tonight? Or what's your schedule? Because I missed your 3 o'clock. Or unless you're just doing 3 o'clocks. And I know mine was kind of hard because we've had some rainstorms and electricity will just go out and the internet will be gone and then they'll come back on and then it'll just be like a winning a prayer. It's like, is it going? Is it staying? What's going on? No one knows. Oh, wow. Whew. I'm tired. But the night has just begun. go live Monday, Tuesday, Thursday, Fridays at 7 p.m., Wednesday at 3 and 10 p.m. on weekends. Okay, nice. So if you guys want to see Robert at work, man, like it. I know, I needed to start feeling comfortable with calculus. All right. Yay! Thank you, Jazz. I appreciate you. No, thank you. Thank you, thank you, thank you. Okay. Anything to help you guys make math easier and be a little more organized. Not a problem. Because some people just like to give kids packets of paper. Oh, here's a suggestion. Almost forgot. Because someone asked me this once before. How do you study with math? Here's the thing. You need to use your notes. Your notes is not just to use for penmanship. Okay? You need to use your notes as an answer key. So it's almost like, okay, say I have this problem here, right? I copy it down on a separate sheet of paper. Okay, here's a separate sheet of paper. I copy down my problem on a separate sheet of paper. I take my notes. My notes go bye-bye. I don't have it even open. It's gone. And what I do is I sit here and I do the work on the separate sheet of paper. So when I do the work on the separate sheet of paper and I think I'm done with the answer, that's when you bring the notes back. And now you're using your notes as an answer key. And a lot of people think that, well, I already did the problem before. Like, why should I do it again? Because before you didn't do the problem. Either your teacher did the problem and you copied it down, or you were just writing stuff and you had no idea how you got from point A to point B. So now, by using your notes as an answer key, you don't have to go running all over the place on the internet trying to find worksheets all the place. You can use your stuff that you currently have. Okay? So you learn basically math. You don't just flip through pages. You can't study math like, yeah, I got that. Yeah, I did that. Yeah, I remember that. Okay, that's not how you study math. Okay? That's usually where you're kind of like picking up on some language and all that stuff. But for math, you have to practice. That's how you study math. I don't think too many people actually tell you how to study math. They just say, you got to study. Okay, how? Show them how. How do you want me to study? All right. So tomorrow we're talking about limits and infinity. Ooh, okay. Definitely need to see that. Wait, hold on. Tomorrow's what? Yeah, I won't be able to come. I'll try. I'll see what happens at the end of this session. Okay, we'll see. All right, everyone. Thank you so much for the likes, the love, the appreciation. I'm going to get everything situated for tomorrow. If anybody wants to do it tomorrow. If you don't want to do it tomorrow, we have Saturday and we have Sunday for those mock practices. Let's just do it up. All right. I will see you guys. Have a great night. And hopefully I'll be able to get to bed before 3. Yay! See you guys tomorrow at see you guys tomorrow night at 9:30. If I come on at 11, it's just going to be something brief, probably selling my wares. Okay, so it's not going to be like a math related thing. So that might be in the morning. All right, but definitely doing math tomorrow night, 9:30 Eastern Standard Time. All right, bye.